Okay, sorry you guys. Hello? Okay, so anyway. Alright, so let's go ahead. Okay, convergence of a geometric series. Now, on these things right here, when we have that R, in my R value, it's got to look like this. It has to look like this. If it doesn't look like this, I have to make it look like that. Okay, I'm going to do some factoring. I'm going to do some crazy math. Super crazy math. Okay, like ridiculously crazy math. That you're going to say, where did that, what? And then when I show you why, you're going to be like, that makes sense. That is true. All right. Anyway, all right, so if R is going to be less than 1, absolute value R is going to be less than 1, then the geometric series converges, and its sum, you're going to find that it's going to be equal to A over 1 minus R, which whatever my R is. And if it's greater than or equal to 1, the geometric series is going to diverge. It's going to be divergent. Okay, so now we're going to go through and do some of the math here. So now, is my R, in this case right here for this first one, is that one right there going to be less than 1? Yes, that is less than 1. So therefore it should converge, right? What is my A value here? 8. Okay, so it's going to be 8 over 1. What's it goes next? So it's going to be 1 minus R, right? Minus R, which is 2 or 5. What's the common denominator of the whole thing? 5. There's only one denominator, right? So multiply everything by 5. Okay? Top and bottom by 5. So that's going to give me 40 over 5 minus 2, which is 40 over 3. Does that make sense? Questions? Okay. Can I erase this? Because I'm gonna be. We got a whole bunch on here, so. Next one. So, is my R, the absolute value of R, less than 1 here? Yeah. Yes, it is. So therefore, it's going to converge, right? So this is going to be convergent. So therefore, I have a slight issue on this, though. I don't have what? A. I don't have an A.
Wouldn't it just be 1?
It'd be what?
Wouldn't it just be 1 then?
It'd be what?
1?
Okay, why do you keep saying 1? Remember, this is my R, isn't it?
Yeah.
Okay, so in this case, it could be 1. So if I do that, let me see. Is this the one? No, the next one's the creepy one. Is that the next one? No, next one's not creepy. That one's creepy. This one, D is creepy. D is creepy. So that one would be 1. Yeah, you guys are right. Yeah, you're right. Okay, so that one's going to be 1. Because I was actually thinking about this one right here, because this is the special one. Ooh, that one's like that crazy math. You're like, yeah, you're going to do that weird cringing smile thing that you do. You're like, yeah. You know that one right there? You're like, you're not really smiling. You're like, oh, it's more of a grimace. Okay, so yeah, let's say that's 1. So in that case, that's going to be 1 over, what's that going to be? 1 minus, right? 5 over 9. Negative 5 over 9, which is going to become a plus, right? So common denominator is going to be, say 9. 9 over 9 plus 5, which is 9 over 14.
Jennifer Rubio Serrano, please report to room 5 to the registration office.
Right.
Jennifer Rubio Serrano, please report to the registration
All right,
office.
so next one. Can I erase? Sure, okay. All right, next one. C. Is my R greater than 1?
Yes.
Yes. So therefore, if it's greater than 1, that means what? It's divergent, so it's not going to converge. Yes? Okay, so that one right there, that one should be easy. Woo! That one's divergent. All right. Okay, on D. So on part D right here, this is the creepy math. But it's actually really not that bad. Because I have to be able to rewrite this thing. So I'm going to rewrite it in the form of a r to the k minus 1, right?
Yeah.
Okay. Good. Good. Now, I'm going to rewrite the r value. Since I'm rewriting the r value, isn't that going to be parentheses 1 over 2 to the k? Is that true? Yeah? Okay, so that one's going to be okay. But now, is it to the k minus 1? Maybe. Say maybe. Maybe. Now, this is where the interesting math comes from this. So here's my interesting math. I'm going to show you, and I'm going to show you with numbers, because the numbers will make sense. And then when you throw it in there with what I'm doing, then be like, oh, okay, that does make sense. So if I have this, come on, don't run out of ink. You just stop. Oh, there we go. Okay. All right, so it's going to be 1 over 2 to the 5th. Right? Could I rewrite this as 1/2 times 1/2 to the 4th? When I'm multiplying those bases, what do I do with my exponents? I add them, right? Okay, so I'm going to add them. But then what happened to my 5? I subtracted 1, didn't I? So I subtracted 1 from that to now, if I were to still add these, would this still be my 1/2 to the 5th? There it is. So now think about it with the variable now instead. So now I'm going to rewrite this as, how am I rewriting this? 1/2 times 1/2 k minus 1, right?
Yeah.
Woo! That's what I said. There's that cringiness that you're like, it makes sense. And you're like, oh, that's interesting. Yes, that does make sense. Okay, so now what is my a value in this case? Oh, actually, no. Start off again. What is the r value? Is it less than 1?
Yes.
It is less than 1, so therefore it's going to converge. So since it's going to converge, let's go ahead and plug it in. So it's going to be 1/2 over 1 minus r, which is what? Dang it. Okay. Yes. Common denominator is going to be what? 2. Multiply everything by 2, right? So if I multiply top and bottom by 2, so that means that's just going to give me 1 over 2 minus 1, which gives me 1. So this whole thing, this whole sequence will converge, the series will converge to 1. Is that super neat? That's like, you're like, bam, that just happened. All right, so like I said, that's that tricky math right there. All right, can I erase? Okay. All right, so now where are we at? We're at E. Now, I want you guys to look closely at this one.
K equals 0.
Thank you, k equals 0. K has to equal what? 1, because that is my nth term, right?
Yeah.
That'd be the term that's going in. So therefore, there is going to be another one, isn't it?
Yeah.
So because of that, this needs to go to 1. So do you remember what happened? What had to happen when it changes into equals 1? Can you go get the door? Someone's over there knocking on the door. What happens? So let's go back a page to, here it is right here. It went from k equals 0, right? And starting off here, so now it's going to be k minus 1, right? But don't I already have a k minus 1?
Was that just your K?
Okay, so now I'm going to rewrite it. So it's going to look kind of funny when I rewrite it though, okay? It's going to look really funny as I rewrite it. So that's going to be...
Eloy and Cosmos Cuete, please report to the counseling office. Eloy and Cosmos Cuete, please report to the counseling office.
Yeah. Right?
Yes, right?
K minus 1 would be your K. Technically.
Yes, because I'm going to subtract 1, right?
Yeah.
I'm going to subtract another one for this because what is also missing from here? An A, isn't there?
Yeah.
So now I'm fixing the k value, and I need to try and take care of my a value out of that. All right, so now, so therefore, wouldn't that be the same thing as saying 1/3 to the negative 1 times my 1/3 to the k minus 1, right? Yes? Okay, because I had that right there because I'm negative powers on those. Adding the exponents, instead of just writing k to the negative 2, I need this to be in k to the k minus 1, right? So, from there, what is this 1/3 to the negative 1 going to turn into? 3. So my a value is now going to be 3. So I'm going to have 3 over 1 minus 1/3, which my common denominator is now 3. Jess, common denominator is 3. Multiply by 3, so it's going to give me
Jennifer
9
Rubio Terrano,
over
please report to the administration
3
office.
minus 1,
Jennifer Rubio Terrano,
which is
please report to the administration office.
9 over 2. Okay.
Can I take a water, I guess?
Yeah, go ahead. Okay, and that last one. The last one. Are we ready yet? All right, so now I have a slight issue here. Don't I? I have a slight issue because it's not in the right format, is it? So because it's not in the right format, I need to actually mess with my numbers. But with the rules of the exponents that I've already gone over, 10 k plus 1, right?
Yeah.
And then that's going to be over 9 to the
K minus 2.
k minus 2. All right, so I need to turn my 10 to the k plus 1 into k minus 1. So what do I have to do? I have to take out something, right? How much am I factoring out? Remember, when I had my 1/2, was 1/2, right? 1/2 to the 5th, right? And I took out one of the factors, didn't I? And I subtracted, didn't I? As I took it out. Yes? Okay, so now, as I did that, that means that things stopped working again. All right, so I'm going to take out. So that means that's going to take out what?
10. Or would it be
It's 10 to the...
K plus
No. Okay, remember.
1, right? Or the 2.
2.
Because
It's
we
going to be
want
2, right?
negative, right? Yeah.
It's going to be 2 because I
Negative
basically
1, right.
I basically need to do that this has to change now into minus 2, right?
Yeah.
So I have to take away 2 from that. So to take away 2, that means I'm going to factor out 2.
2 powers, yeah.
Okay, so that's going to be a 10 squared, right? So in those terms, that means that's going to be a 10 squared, right? 10 squared times 10 to the k. Since I took out 2 of those, that's now going to turn into
Minus 1.
k minus 1. Over. Now, I have too many there, don't I? How many too many do I have? I have one too many, don't I?
Yeah.
So, since I took that out, I'm going to take out what? So, there's a reason why I wrote it up here in blue as my exponent. Because when I factored it out, I took out that much, right? And so over here, it's a positive 2, isn't it?
Mm-hmm.
So if I'm taking that out and I have too much, right? Now I have too much. So now it's going to become a 9 to the negative 1, isn't it? I have a 9 to the negative 1 times my 9 to the k minus 1. So what's going to happen to that 9 to the negative 1?
It's going to go on top.
Go up to the top. Go up to the numerator. And that 10 squared that's already there, that's going to give me what? How much?
109.
Yeah, so 900. Thank you. All right, 100 and the 900. So I'm going to have 900 parentheses. What goes next? 10. Do they both have the same exponent? They both have the same exponent, don't they? Since they both have the same exponent, I can write it as 10 to the k minus 1. Look at all that interesting math that just happened right there. It is interesting. This is algebra. It's like basic algebra, though. This is really not the calculus stuff. This is just basic algebra, just other ways to use it. Now, you guys ready? What is my R? It's too big. It's divergent. So my R is going to be greater than 1, so therefore it is divergent, isn't it? That's double-sided. Okay. Yeah. Yeah. Okay. That's fine. So don't forget, like, share, and subscribe.
Okay, no promises.
Ah. Okay, express this repeating decimal as a quotient of 2 integers. Quotient means what?
Division. So
Division.
fraction.
Yeah, fraction, right? So it's a fraction, 2 integers.
We literally just have this fraction.
Okay, so let's pretend like I know what I'm doing. Okay, so I'm gonna do a super basic. Super basic. This right here. This right here. Didn't we already do the math on 10 over 11 earlier?
Yeah, and that's why we got 0.090.
Okay. All right. So this one right here is going to give me.
What?
Look at the decimal, please. Hey, you guys, pay attention. Look at the decimal. So what is that going to be as a fraction?
That's 9.
Just in blue.
9 over 100.
9 over 100. God, I could not think of that.
There you go. 9 over 100.
Tenths, 90 hundredths. I was like, what?
Yeah. All right. So the next one's going to be what? So if it's 9 over 100 plus.
Another 9 over 100. Wait. Oh.
All right. You guys ready? I'm going to show you some basic math now. You ready? You ready for this?
Yep. Yep.
Okay.
Cool.
No, that's supposed to be a 0. Sorry. Okay. So together, the basic math says that this is 5, 3, 2, 0, 5, right? So could I write this thing as a sum of parts? Okay? So I have this piece right here, the 0.009 taken care of already, right? Okay, so let's see if we use this same idea of basic math. Okay, plus, it's gonna, what am I adding next? I have 4 now. This one I had 2 decimals, now I have 4, right? So that's going to be 9 over what? 4 decimals, right? Which is,
1,000.
so look, 10, 100, 1,000, 10,000.
It's been way too
I'm telling you, it's a little bit too basic.
It's you guys' turn. Yeah, I'm not talking.
All right, so next one. So what's the next one going to be? You guys understanding what I'm saying, though? It's
Yeah, no, I get it. Yeah.
it's the little things that are throwing it off.
Yeah. I thought it was millions, not 10,000.
Nah, it's fine. Okay, so now that was 2 decimals, 4 decimals, right?
No.
How many is going to be next?
5. Oh no, wait, because we're gonna skip 6 now, right?
6. Okay, good. So it's going to be 9 over
100,000.
how many decimals?
So 100,000. Or 10 million. A million. Okay, we were in the first time.
1 million decimals, right? Okay.
It's insane. I thought it was.
All right, 6 decimals, right? Because I start off with 2 decimals, or I'm sorry, 2 zeros. The next one's going to be 4 zeros. And then after 4 zeros is 6 zeros. Okay. All right, so now let's do some factoring. All right, so now I need to be able to rewrite this in terms that I could actually do. So what's happening every single time?
Slowly getting smaller.
Smaller, 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 right? Keep going like that, right? So the way that I'm going to write this out, since I have this, I know that it's going to come out to be, okay, because of how the pattern repeats, right? Okay, because of the pattern repeats off of this, they're all going to have the same value. They're all going to have the same value on the outside. So it's going to be factoring out that, so it's going to be 9 over 100 times 1. Is this one? I think this one's plus.
Plus, because you're.
Yeah, this one's plus. Okay. So if I took out that value, so on the top, if I divide 9 by 9, I get 1 over. Now I took out 2, right? 2 decimals. So what's left over? Okay, so right here, take out 2. So from right there, I took out all of that, so that's 1. And now it's going to be 2 decimals, right? 100, right? Okay, and so now,
Yeah.
what's going to happen next? What's going to happen next? What's the next one? That was 2 zeros.
So what now? It's gonna be another 1,000.
Yes, now it's going to be 1 over,
Or is it 10,000?
right? Yeah, 4 zeros. Let's just count by zeros. That's easier.
Okay. Yeah.
Yes, count zeros. All right, and the next one's going to be, as I factor this out, it's 1 over 1, 1, 2, 3, 4, 5, 6, right? Dot, dot, dot. Okay, in this case right here, as I keep adding this up, okay, so the next one, every single time, what's happening?
Smaller.
Okay, what is happening? Am I getting exponential here? As it's growing exponential, right? Okay, so now because of this, oh crap, I was supposed to give you, I think I give it to you later. Or did I give it to you? No, I was supposed to give it to you earlier, but we'll find. All right, on this one right here, it's going to come out, because it is increasing that way that it is, it's going to be, every single time, it's actually adding more and more to that. So it's going to be 9 over 100 times 1 over 100k minus 1. Okay, because it's growing exponentially. right? Every single time the term keeps going up by that amount. Because every single time I'm adding another one, as the terms go up, I get 2 more zeros on the bottom, right?
Yep.
2 more zeros for each one that I'm going with. So if I'm doing my first term, let's see if I get that one. First term would be, so 1 would be 1 minus 1 is 0. Anything to 0 is 1, which would give me my 9 over 100, which is my first term, right?
Yep.
Okay, so now that I have this, so is my R value less than 1? Say yes. R value is less than 1. So since my R value is less than 1, so now my A value is going to be 9 over 100. So I'm going to equal 9 over 100, okay, times 1 minus R, which is 1 over 100, okay? Common denominator is 100, right? So that would give me, multiply that out, that's going to give me, what does it give me? 9, yes? Over, okay, as I distribute 100, that's going to be 100 minus,
It's 9 over 1.
minus 1, right?
Yeah.
So it's 100 minus 1, which comes out to be 1 over 11. Ah, dang it. Put 1 over 10. 1 over 11.
Yeah.
Let's see what my calculator says. 1 over 11. Oh, wrong screen.
Tap over.
So we get scratch pad 1 divided by 11. And oh crap. Control it. There we go. And what was the other one that we had earlier? Say 10 or 11? Or 11 over 10?
That was 9090.
9-0. So that was it 10 over 11?
Yeah, so yeah. Yes, it was.
There we go. Yeah, so it was off by a factor. Factor of 10 there. Okay. Bam. All right. So you guys are going to have to go through and be able to, I think this is the last one. Yeah, that's the last one. This is the last one right here. All right, so you guys are going to be able to have to do all this with these to make your own. So if a ball drops from a height of 12 meters, each time it strikes the ground, it bounces back to height 3/4 the distance in which it fell. Find the total distance traveled by the ball. Okay, so what is A? What is my initial going to be?
12.
Okay. What is the R going to be?
3/4. And then K minus.
Okay, so now, so if we're doing this in terms of n, okay, so this is going to be basically the sum as k equals 1 as this goes to infinity, right? Of this one right here, so we got the sum of all this blah, 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 right? Okay, so now as we plug it in, this would go in here, so that would be, all right, is my R less than 1?
Yeah.
So R is less than 1, so that means that this one has to be, it's got to be convergent. So this is going to be convergent. What is my A value?
12.
So that's going to give me 12 over 1 minus,
3/4.
what is the common denominator?
4.
So I'm going to get 48 over, that's going to be 4 minus 3, which is 1. So since I'm talking about the total distance traveled, so it's going to be 48 what?
Meters.
You guys feel good about this?
Yeah.
That's that harmonic stuff right there. Okay, this is geometric series. Ooh, makes you feel good. It feels good. Yeah, it feels good. Okay, yeah, I just did it. Broke a little Tony right there. All right, so another useful series, even though it diverges, is a harmonic. Okay, in this one right here, it is going to be a harmonic of 1 over k. So as it keeps going, because this right here is just 1 over k, it's not going to get smaller, but because it keeps going up, It's going up tiny, 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 tiny amounts. Okay? But because of that, it's going to, it is harmonic because there is a pattern for this. It is a pattern. It is a harmonic. Infinite series, it is called a harmonic series, like that. So, with the pattern, it is going to go up. It is divergent, but infinite series. Okay? Diverges. All right, here's the proof. Summary. Blah, blah. Everything we talked about. Blah, blah, blah. All right. You guys feel good?
Yeah.
Okay. Don't forget, like, share, subscribe.